here. So I want to welcome everybody to our K-12 chat for this month. I get the pleasure of introducing Rob Gould. Rob is a friend and colleague who I've known for many years. He's a teaching professor and vice chair of undergraduate studies at UCLA in the Department of Statistics there. And he's just been a real leader in statistics education and data science education for years now. He has a lot of credits on his, or a lot of experience in that area. He's known for several things. One is he's the original founder of DataFest, which is a 48-hour data competition that now has grown from the one site at UCLA to now over, this may not even be accurate for this year, but over 42 sites around, not even just around the country, but around the world even. So he's done that. He's a fellow of the American Statistical Association, and in 2019, not that long ago, was awarded the Lifetime Achievement Award in Statistics Education by the Consortium for the Advancement of Undergraduate Statistics Education. It took me a second to remember what the cause stands for. But anyway, so he's done a lot of work in the area of statistics education, but the reason we've invited him here today is because he's the principal investigator on the NSF-funded Mobilize project, which is that created the course, the Introduction to Data Science course, which is a year-long high school course that's now implemented in a large number of school districts. The thing I saw said 16, but it might even be more than that now. So Rob can fill you in on that. So anyway, with that, I'm going to turn it over to Rob and let him get started.
I think I'm sharing the wrong thing. Thanks, Roxy. I'm out of practice with Zoom, so bear with me for a moment. Here I go. All right. So since this is a chat, please interrupt with questions, and there aren't that many of us. If you don't interrupt somewhat rudely, I'm just going to keep plowing on, and I'd rather talk about things as they arise.
I can't see your screen, Rob. It went black.
How about now?
No.
Let's try it again. Okay, stop share. And now I can do.
Now we're seeing your news feed. Or no, is that my news feed? Yeah, sorry.
Can you see it now?
Uh-huh.
And if I hit play, I wonder if you'll be able to see it.
No.
Okay, so I just won't hit play. All right. So you'll have to make do with, let me try it again. You have to make do. I guess I'm really out of practice.
You can try hitting play in window. That also works. You can show
that's
that
what
window.
I was trying. But you should be able to see it now, right? It just won't play, but that's okay. There are no special effects. In any case.
Well, it just went away again.
It did. I don't know what to
now,
do.
Oh, you're teasing. Now I can see it. Now I can't.
Well, I can just talk to you. Because I don't.
Is it a PowerPoint?
Yeah, I could try. Well, let's try. Okay, well.
Because you could send it to me and I can try and drive it if you want.
Yeah, so talk amongst yourselves. I got it in Keynote, so let me try to export it to PDF and I'll just do that. Okay. And see if that works.
While we're waiting.
It sounds like it's something worse than that, so I'm a little nervous.
When you're sharing your screen, there should be an option for letting it show the presentation.
Yes, there should be.
While we're waiting, I'll point out that Rebecca has put a link to US COTS in the.
I'm afraid I have to log out. I've now lost control of my computer. The whole screen is breaking down. So I'll log out and come right back in.
Okay. we'll chat without you. All right. All right. Well, welcome everybody. How's everybody doing? Josh, yeah, we got Josh Tabor here. Why don't you tell us what's going on in your AP Stat world?
So I did my last new content today for AP Stats in my class, and we have spring break coming up, and then it's busy time for AP Review coming up. So that's it's always exciting to get into that. The kids don't necessarily love all the assignments they get, but that's fun. Sad I can't go to the Beyond AP Statistics, but I'll already be doing sort of reading stuff at that point if on the sort of early leadership team.
Yeah, two of our presenters have to have requested morning times because they leave right from there to go to the reading. So
that's right. Yes, and don't delay them. We need everybody we can get.
So good. How's everybody else doing? Anybody else got anything interesting going on while we're waiting for Rob to get back in, which hopefully he will be able to do?
I'm looking forward to going to Scott's this year.
Oh, are you going to come?
I am.
Oh, that's great. Have you been before?
No, this will be my first time.
Oh. Are you able to stay for the Beyond AP? Do you think that's will be the day after?
Yeah, I might. I have the option. I'm master of my own schedule. So.
Yeah, that'd be great. So yeah. Let's see. All right. Well, I'm a little worried that Rob hasn't popped back in yet. Josh's bobblehead is there. All right. Josh got that bobblehead at the AP reading. Or was it from the AP reading? I know Chris got hers there. But that was before Josh's hair went gray. So let me see if Rob, maybe I should text Rob and ask him where he is. Chris, why don't you talk for a minute and I'm going to see if I can get in touch with Rob. You're muted.
So Rob, where are you? I know Rob has a great presentation plan for you. You think I need to? There he comes.
He's back.
Okay, let's try this again.
You might need to make him a co-host again.
Yeah, I'm making him a co-host right now. Okay, you should be able to share your screen, Rob.
Okay, let's try this one more time. Okay, can we see the screen?
I can see your screen.
Can we still see the screen?
No.
Okay. Now we can see the screen?
We can see it, yeah.
Okay.
So let's just click through for there, yeah.
Okay. Technology. Ironic, isn't it, that that's the theme of this talk? So there are basically three things I want to talk about on the notion of what is data science and what role does it have in K through 12 and do we even need something new? So I'm going to start out by talking about what I see is statistics, and why there might be a need for a new course that's not statistics, or maybe not statistics. I then want to talk a little bit about the curriculum that Roxy mentioned, the Introduction to Data Science curriculum, and give you 3 sample lessons from that curriculum, just so you kind of get a sense of what could happen in a data science classroom. And then I have a conclusion that's kind of a very opinionated sermon, I guess, for lack of a better word. So with that in mind, now's the big moment when we see what happens if I change slides. So one view of statistics, at least. Oh, I'm getting some, if people commute, I'm getting some echoing back. Of inferential statistics is basically, it gives us this guarantee that if we collect data under certain conditions, random sampling and all of that, we don't need to see everything in order to estimate what we would see if we could see everything. And even better, under those conditions, we can calculate uncertainty. So we can be certain of our uncertainty. And in beginning statistics, and I use that phrase because people begin statistics at different times in different schools and districts. But the goal when we begin to learn statistics is to basically understand why this is true and when it is true and when it's not, and how to carry out inference in some usually fairly limited situations. Limited just given the scope of all the science research, but as you all know, quite a bit to talk about in a class. Is that all that statistics does? And the answer is no. Statistics also works with exploratory data analysis, a term in an area invented by Tukey in the 60s. It's about being able to learn what features are in a data set, how things are related, to explore the data set. Tukey, I think, was the first to talk about the science of data. So that phrase, that notion has been within statistics for quite some time now. Descriptive statistics have always been a big part of the field of statistics. So, Florence Nightingale and her attempts to convince Parliament about the horrors of the hospitals in the Crimean War, and Francis Galton's work, and all those 19th century foundational efforts are all, about to include a lot of descriptive statistics. Predictive modeling is the sort of modeling where we use data to try and predict, what products a person is going to buy and what movies they want to watch and what commands they want to really type into the computer and what their computer should do. That's long been a part of statistics also. In the early 2000s, statistician Leo Breiman argued that it should be a bigger part. He kind of said that statistics consist of two cultures, an inferential culture and a predictive culture, and the predictive culture needed greater emphasis, and we've seen that emphasis grow quite a bit. What was called statistical learning, and now is kind of subsumed into machine learning. And then there's computational statistics. So statisticians have long worked with computers and tried to understand how to best calculate something given the computation, the technology that was at hand. According to at least one paper, this goes back to the 1930s, is kind of the founding of computational statistics. So statisticians have worked with computers for a very long time and computational issues for a very long time. So it seems that maybe statistics does encompass much of data science, but there have been some changes that we should talk about. The biggest is to the notion of data. So, David Moore and George Cobb defined data to be numbers in context, but we now see data that's much more than numbers. We see words, music, videos, photos, all sorts of things that are not, maybe they get reduced to numbers at some computational stage, but we don't necessarily want to think of them as numbers for our analysis purposes. They're often not gathered using traditional statistical paradigms. They may be an entire universe of data. Everything that anyone has ever typed into Google is, in theory, accessible to someone somewhere. Or they may be collected through satellite or streams or other kind of non-random things. And the biggest change is they're ubiquitous. I mean, when I was in graduate school doing my dissertation, I had to hunt for someone who had some data I could use, and I had to use the same data set through the whole project. But students today are surrounded by data. They know of the term. It's a part of their everyday lives. So it's no longer kind of this thing that they may see someday in their professional lives. It's something that they're living with. Computing has gotten cheap, as we know. Software is much more accessible than it was before. I think another interesting thing to point out for one change is that computer science is making headway into K through 12 as an area of study. So we're going to have more and more, we are having more and more students in K through 12 who know about programming, maybe can program, know much more about computer science as a discipline than was known before. So those are all some of the developments. I think we've also learned that data can be dangerous. So we all know that data breaches, we can lose our financial control of our finances, we can lose control of our personalities. But we also have seen more and more evidence of certain, that book, oh gosh, what's it called? Weapons of Math Destruction talks about how algorithms, when they're applied to data, can exasperate racial and social inequities. So they can make our problems worse if we're not careful. But there's also a lot of promise to data. So we can now teach students how to analyze data, and it can be their own data. We can teach them to kind of enough tools to analyze data to kind of have greater control over their own lives and their future career goals. So all reasons for change. And that leads me to this kind of thought experiment. One of my goals in a statistics education is for students to be able to carry these tools with them into their everyday lives, or at least into the next classroom. And so as a little thought experiment I gave myself, I said, well, let's look at some types of data and see if this can actually be done. So I just want to look at three types of data that students might encounter, and see if I think that with what I've taught them in my class, and I ask you to think the same thing, with what you've taught your students in your class, could they analyze these data? So the first comes from the GAZE pre-K through 12, the original version. Roxy and Chris were co-authors on, and maybe others on this call too. I can't see everyone anymore. There's a lot of detail given here that's great context about how the data were collected. Basically, this is an experimental study. Seeds are going to be randomly put into one of three conditions: 24 hours of darkness, 12 hours of darkness, or 0 hours of darkness. Each seed was randomly chosen to be put in one of 4 bags. So we have 4 bags of seeds and 3 experimental conditions. So 1 experimental condition gets 2 bags. So that's some of the detail behind this. Great detail. Here's the data as it's presented. So this is a nice way of presenting the data to humans. It's easy to read as long as we understand that because of publication technicalities, this first column is continued over on the right because it wouldn't all fit on one graph, I mean one page, and or one, you know what I mean. So there's some things done there, but can a student analyze this data? Is this the format that they're ready to go? Well, they can if they have a calculator and they're willing to re-enter all of these data in, even though they've already been entered into some sort of computational form. But the students themselves collected this data presumably by hand. I mean, they grew the seeds, they put them in the bags, they did it themselves. So what's the process from writing that data down to getting it into the computer to be analyzed? If they're using a package like CODAP or SPSS or R or Python, it's not going to be able to analyze the data in this structure. And so they're going to have to restructure it along the lines of something like this. So this is sometimes called the case attribute or spreadsheet structure. Each row is one case, which in this case is a seed. And the columns tell us all the known attributes of those seeds. So an arbitrary identity number, something that tells us which bag it's in, and then the experimental condition, how many hours of darkness did it get? And then the response variable, how big did the seedling grow? And so this format has a lot more, captures some additional information that the other format didn't necessarily capture, but has the advantage that it can be analyzed by most statistics packages. And now someone's knocking at my door. It just never ends. So the point of this, though, is how do we get students to this stage? If they see the data like this, or if they've seen it in their handwritten version, how do we get them to get it to this stage where it's ready to be analyzed? I mean, do our students already know how to do this? And at least in my class, the answer is no. I usually start with the data in this form, and they don't necessarily know how to get it into this form. I'm going to come back to that idea later. Another example of a data set that might be interesting to students is this comes an open data set. One of the beauties of the modern world is many governments have open data. It's kind of all around us, and we can access that data. but the fact that we can access it doesn't mean it's accessible. And this is kind of one example. This is a data set that I think students would be interested in. This is data about every person who was stopped by the police department, and it could be used, for example, to understand if there are biases in patterns of policing and who they choose to stop and who gets inspected as a result of these stops. So it's a hot issue, and students could reasonably be expected to be interested in this. I don't know how well you can see that, but here's a description of the data. It has 8.4 million rows and 16 columns. And down this side is a description, and every single variable is a text variable, except for one that's date and time. And that date and time variable isn't ready to be analyzed. It needs to be processed somewhat before you're able to extract information from it that you could use in an analysis. So I think most introductory statistics students are first of all going to be dumbfounded by the 8.4 million rows if their computer can access it. And the 16 columns is also going to frighten them because they may not have been exposed to data sets that had more than 3 or 4 columns before. And then there's not a single number. So are our students ready to pose questions to data sets like this and then to be able to analyze them in some way to get a handle on those questions? And I think, for the most of us teaching an introductory statistics course, the answer is no, they're not ready for data like this, even though it's out there and it's something a student is likely to find on their own and be interested in. And my last example, which is really tiny, is the NBA. So a lot of students, if you give them a project, they're going to think of sports. NBA has great statistics on its webpage. And you're going to go to them and their students may have fun scrolling through, but how are they going to get these data from the web page into their computer? The answer is with great difficulty. It's going to be hard. So this data, even though it's plentiful and accessible, is not ready to be analyzed and takes quite a bit of work to analyze. So I mention all of this because the lessons that I'm learning, that I learned from this thought experiment, is that I may have prepared students to work on data that is nice, that's data from my class, that's I've prepared, that's theoretical in some sense, well, in the sense that it's not like data they're actually going to see. So for good reasons, I'm teaching them in my statistics course to analyze data that's been pre-processed, but that pre-processing doesn't prepare them to work on data that they'll see in the real world, doesn't necessarily. It's a big ask to ask for one class to prepare all students to be ready to work with all data that they'll see in the real world. And that's not going to happen in a single class. I'm going to argue later that we need to do it over several classes. But the point is, one reason for having a class in addition to a statistics class is to help with this sort of a process, to help prepare them for these data sets that they're going to encounter in the real world. So the GAZE, as many of you know, the GAZE report was updated in 2020 and took a lot of these changes into account. One of the changes was to revise the statistical investigative process. So it used to say formulate statistical questions, and now is statistical investigative questions to emphasize the investigation role. But a big change was collect data changed to collect and consider data, to reflect the fact that students are most often going to be working with these found data like the NBA data or the LAPD data, that's data that has already been collected. And so they need to learn how to interrogate that data to make sure they understand its provenance and whether it's suitable for their questions that they're posing, and whether the data themselves have issues that make it usable or not usable, and so on. Another change is the role of technology. In 2005, the word appeared in the GAZE report 4 times, and in 2020, it appears 50 times. So a big input. In the first report, technology was recommended. In the second report, it's technology is the priority for students to learn how to use technology. So as statisticians, I think we've taken some big steps towards addressing these changes in the world of data, and that move us closer to data science. But I think there's room and a need for another course that teaches those data science ideas a little more pointedly. And so I want to kind of just give you an overview of the curriculum, the IDS, Introduction to Data Science curriculum that I've been a part of. It was developed based from an NSF grant, and it was a cooperation of the Los Angeles Unified School District, our stats department, computer science department, and the School of Education. As Roxy kind of said in the beginning, it was at first just taught by LAUSD in those 10 classrooms, but currently it's taught in 150 high schools. And at this moment in time, there's roughly 8,000 students taking the course. And we used to be the only course. There are several curriculum out there now. There's even another curriculum from UCLA by Jim Stigler in the Department of Psychology. There's one out of Stanford from Joe Bowler's group, and one in out of Brown University, the Bootstrap course. So it's becoming a crowded field. Our course is available under Creative Commons license. That's slightly deceptive in that you can see all the materials and you can do with them what you want, but our course is pretty technology dependent. For example, the students use RStudio, and you have to go to RStudio and get their license for that. And we also created a big bit of technology I'll show you in a little bit. You can download the code from this site, but actually running it requires quite a bit of technical expertise and equipment. Our course looks like this. The year is divided into 4 big units on general themes. Each unit ends in a practicum, which kind of ties together the previous week. Each unit contains what we call a participatory sensing campaign. I'm going to show you an example of that in a couple of slides. And the daily lessons come in 2 flavors. One is student-centered activities that are designed to build conceptual understanding, terminology, and skills. And those usually involve students doing things and the teacher then kind of channeling that activity into a classroom lesson and summing things up and leading a discussion. And also data labs where the students work using R on RStudio, where they apply the concepts that have been learned to learn some basic R coding and data analysis. And those labs happen between 1 and 3 times a week, depending on the subject matter. The curriculum is strongly centered on the GAZE statistical investigative process, which we've tried to make a little more pithy and called it the data cycle and created a nice looking, I think it's a nice looking logo. We haven't yet updated the tags to match the new GAZE things, but we will soon. And we spend lots of time on this asking questions phase. A large part of the curriculum teaches students how to ask constructive investigative questions, which was something we found really important. When we piloted the class and we didn't have that, the class did not go poorly, and including these sorts of lessons really improved the learning quite a bit. So I'm seeing some questions in the chat, and I don't I don't know about whether ChatGPT can help. And I don't know about the AP Stats course, but many people in this chat know more than I. So maybe we can talk about those in the end. I mentioned this notion of participatory sensing. This is a data collection paradigm that Deborah Estrin, who is a computer scientist at UCLA, developed. Basically, you use your cell phones, mobile devices to collect data, but there's a whole infrastructure that's designed to make that happen within a community, and a classroom is a natural community. So basically, students use their phones to collect data. They act as human sensors. It's a non-random data collection. They get information in form of numbers and pictures and words, and it all stays within that community. And so they all together kind of work on a problem where they collect data, they share the data, and they analyze the data together. Our first campaign is not terribly groundbreaking, but it's about the students' snacking patterns. So whenever they eat a snack, which we define as a food or beverage taken outside of mealtime, they pull out their phones and they answer questions about it, including taking a picture. And then the first practicum or checkpoint asks them to engage in this data cycle and show how they went through what they did in each of the 4 stages to address with these data. So they have to talk about their investigative questions and how they collected the data and discuss the quality and do an analysis and answer their questions. I'm just going to go over this really quickly, just some pictures, but what this looks like. So this data comes from me. I ate a snack. I pull out my phone. I say it was a banana. I answer questions about this banana, and I take a picture of the banana. And now this all goes into the group's database. And there's a tool that lets the students then explore this using a dashboard interface. So, I can't remember, well, none of these points is mine, but my point with a little bit of jittering, so to protect my anonymity would show up somewhere on this map. And this dashboard gives students a way of exploring the data as a multivariate whole before they have R skills that would let them analyze things. So it lets them get involved in question posing and analysis before they've developed the data analytic skills that come from R. It's also kind of a great way. There's lots of other lessons that could be extracted from this. I'm just going to go over the next kind of quickly, but they then produce posters at the end that show how well they understood this data investigative process or what they didn't understand. And there's a little bit of both in these examples. The second lesson I want to share with you is, for some reason, is my favorite. And this goes back to this data collection notion. The students have 16 of these cards that represent people, imaginary people. And as a group, they're asked to collect data about these people and organize it on a poster in any way that you feel is helpful. So very general instructions. So the teams create a poster, they put them up on the wall. They then do a gallery walk where they walk and they make note of similarities and differences and what their preferences are. And this gives the teacher an opportunity then to kind of steer them towards that spreadsheet format, that case attribute format, and lets them kind of see that process of going from data collected by hand to putting it into a more formal format that the computer is ready to analyze. And I'll show you some examples. This comes from students. So they organize the data by variable name, and then within each variable, they sorted from biggest to smallest. And this is a very common format that students will organize their data in. If you just say, organize your data as we did. This is based on a research project by Cliff Knold and Bill Finzer, and someone else whose name I'll remember in a moment. And they also found that this was the sort of organization that people were comfortable with when they were beginning to think about data. This is another group that moves us a little closer towards the case attribute format. They've considered the names, they've got cases here are people. They've used the names as labels instead of variables, but otherwise they're getting closer to that. And finally, one group actually, and I think this might have been actually during a professional development, this one might have come from teachers, but this is kind of the format that is called the case attribute format, where each row is a case and each column represents the attribute that we're measuring. And Knold, Finzer, and Creton show that this is not a natural format. This is not the way people naturally think of data. And this was a big aha for me, because this is the way I present data to my students. And I always thought I was immersing them in real life. But what this showed me is, to them, this is actually an abstraction. It's removed from the original process where the data were collected and organized in some other fashion and artificially put in this artificial format that is useful for some purposes, but maybe not useful for others. And so this is one activity that gets students to think about how to structure data. The third activity I'll go over really quickly is the horror movie shuffle. So in this course, we don't teach formal statistical inference, but we do build up the ideas of inference using permutation testing and such. And this occurs towards the end of the course when they're fairly comfortable using R. And we have data sets on slasher films and the protagonist in the film and who lives and who dies. And they're asked, whether they think there's a difference in the gender of who's more likely to be killed. I'm just going to quickly show you, there's just lots of R code here in which they look at the data set and they learn that about 77% of the females die and 87% of the males die. And then this is, by this time they've learned to ask, but could this difference be from chance? And R gives them the tools for simulating this. And again, I'm not going to go over this now. And there's a lot of scaffolding to get them up to this point. But this is the final product that comes out from a perfectly executed set of code that takes quite many tries for students to get to. But the producing is basically a sampling distribution that looks like this. And then they're asked to compare their actual outcome to what they got. Now, this falls for me in the realm of informal statistical inference. They're thinking about what does it mean to say something happens by chance. They're simulating chance environments. They're making observations about what chance looks like. And they're asked to kind of formally assess what their thoughts are, given that the outcome looks very similar to or very different or is very common or very rare from what they saw by chance. We're not talking about p-values. We're not defining them. We're not even calling this a sampling distribution. We're just letting them reason this way. And that's as far as we get in this course towards that, which I would argue is quite a long distance to go. Okay, we've reached the sermon part. Basically, the sermon part is where do we go from here? And my answer to that question is that we need to spend more than 1 year developing student statistical understanding. It would be great if we had 2 years in high school. I don't think many schools would go for that. 2 years of statistics, a part 1 and a part 2, but 1 year of data science and a 1 year of statistics might just fly, given that they've got 2 different titles at least. And we could argue that they're 2 different courses and 2 different subject areas. And I think a curriculum like IDS and other data science curriculums could go a long ways towards developing the foundational work, the conceptual foundational work for formal statistical inference that would allow a statistics course to build on in a much stronger way than it's able to do now, where it has to teach everything from the very beginning. I think there's a great need for this. I would argue we're living in a time of a data literacy and a statistical literacy crisis. We've heard about the problems with scientific reproducibility. We've heard about the p-value crisis, where even scientists who've had presumably graduate level statistics courses are still misinterpreting p-values and confidence intervals in their own research. The recent TikTok hearings, they've been focusing on the role of communism in social media, but really the issue there is, in my mind, is why do we allow any company, any corporate entity to have so much personal data if the data is every bit as powerful as they're claiming it is? What have we done? How have we allowed ourselves to get to this stage? And one answer is we haven't been educating people in data literacy and the impacts of data and what can be done with it. So I think we're in a crisis time. If it's true that we're bathing in a sea of data, then I would say that we're not teaching anyone to pilot the boats, much less to catch fish to feed the people on the boats. And I can't continue this metaphor too far, but the basic idea is that we're not prepared. We're in a situation as a culture and a society that we're just not preparing people to deal with. We can expect everyone to learn this in 1 year. And so the 1 year of statistics in high school and AP statistics is necessary and fundamental, but it's far from enough. And I think by creating data science classes and thinking of this as a complement to statistics classes, we can kind of forge an educational pathway that will give students the knowledge they need to make better decisions than many of our politicians are making now, and also to create pathways that let them learn to take control over the data in their own lives. it used to be when I was a student that you couldn't really, it was believed you couldn't analyze data until you learned lots of mathematics, because the only way to understand the analysis was through understanding the math. But we have a lot more tools now that can teach students a lot of data analysis in a lot of careful and critical and constructive data analysis ideas before and without all of the mathematical framework. So we have a need to teach more, and we have the means to teach more. And so I think we should be teaching more. And that's where I'll end then the discussion and the sermon. So thanks.
Well, thank you. Thank you, Rob. One question that came up in the chat is whether you're willing to share your slides
Of course.
With the group. So if you, maybe the easiest way to do that would be to send them to Rebecca. Is that Rebecca? Are you?
Yeah, that's no problem.
And then you could send them out. So that would be great. So anyway, well, thank you, Rob. That was interesting and informative. Let's open it up to questions now. We've got some time left. So Mary Lou asks, how can they access the IDS course?
Yeah, so I'm typing in a web page now that has all the information, and that gives you the materials. To access the technology, that's something where you have we work at it with the district to kind of sign a contract, because two things is, one is we want to make sure that we're providing professional development support. And the other thing is we want to make sure that the technology bit is being handled well. The technology infrastructure is substantial in this course. And we've learned the hard way that school districts can't do it themselves. And so we now do it for them. But all the materials are there, and you're welcome to that. Cynthia asked about the geometry prerequisite. Yeah, in terms of having, it's more about having 2 years of math than having geometry. So it's not as if we do proofs of geometry things or require that, but some schools, I mean, in the early days when we had researchers who could study it, we just found that the students, who had 2 or 3 years of math did much better in the course than the ones who had only 1 year of math in the course. And since at most of the schools that we've been working with, geometry is the second year, that's kind of why that's a requirement.
Are there questions? Feel free to unmute and ask your question if you'd like.
Dr. Gould, I'm worried about the, I teach a data science class using using Python and Python libraries. And I was forced to try to pack it all into one semester, which is really crazy. But they told me baby steps and accept this, because you may, if you push for a year now, you're not going to get a year now. So take your semester and be happy. Anyway, the pushback I'm getting is not from the course itself, but the strong feeling that people in our community have that students have to have pre-calculus, and preferably calculus, before going off to college. And they're grumbling to give me a 1 semester data science course. I'm going to have to fight tooth and nail to get a full year. I want 2 years, but I don't think I'm ever going to be able to get it until something changes in college admissions.
Well, I mean, you've hit the nail on the head. I mean, that's the big issue, is where does this fit in? And unfortunately, it's seen as a zero-sum game, where if you offer a new course, you have to take courses away. I don't have an easy answer to that. My motivation is, like I said, that I think we're in a data literacy and a statistical literacy crisis. I don't think we're in a calculus crisis. I think people are doing just fine with the calculus knowledge that society is giving them at the moment, which is not to say we can't teach it better and we can't teach more people. and we can't reach out to teach more communities calculus than we are right now. But we're not in a crisis with calculus, and we are in a crisis with data in general. And so for me, that's part of the motivation. So it's not an either or, it's a both. It's definitely a both situation. Well, I think all students, my tagline is all students need statistics and data science, and some students also need calculus. But whether all students need calculus is something I would, and whether they need it in high school is something I would question.
Rob, you've offered this course for a couple of years now. What's the feedback that you've gotten from students?
Oh gosh, I mean, students tend to like the course. I mean, we haven't done a formal survey or anything from quite some time, but the students we had one researcher who studied some schools in San Diego who are not just using our course, but were using computer science courses to aid their math courses. And the use of the computer was always the thing the students mentioned. So they mentioned things like they felt that they were given a tool that actually helped them solve problems. Whereas with math, they felt that they just kind of never engaged in problems, and they were kind of engaging and trying to understand what the teacher wanted them to do. And they felt the computer enabled them to solve problems that they wanted to solve. So they expressed the notion that they persisted more in problem solving because they enjoyed the process more. They found using the computer to be more collaborative than they did in their traditional math classes, which is not a function of the computer so much, but about, I think, the pedagogical styles in the more traditional math classes. And a lot of them said that this was the first math class they took that was fun. What my favorite comment to hear from teachers is from several of our teachers have come to us with some version of, this is the first time they've taught a math class and no one has ever asked, why will I ever need to use this or need this? So that's another great reason. So
you've got a question in the chat from Josh Tabor, who will remain unnamed, who says, suppose a teacher wanted to use your curriculum for their own edification, can they? Asking for a friend.
Yeah, you could have the friend ask me and we can see what we can do. There are some real expenses. I mean, for example, using RStudio does cost money, and so we have to kind of work all that out. And so, do you know of a curricula that include data science as part of an Algebra 2 or integrated math course? I suspect there are some. I think, Roxy, maybe if the Carnegie folks are working on that. There is a curriculum that came out of Cal State Northridge that uses statistical concepts as part of an Algebra 2 pre-calc course. But my sense is it's kind of light on the statistical concepts. It kind of gives it a mathematical context. And can students, Robert asked, can students take the course independently like with Coursera? And no, it has. In fact, we're only doing contracts now with districts just again because of the technological infrastructure of our particular course. But like I said, there are other curricula out there that you might want to explore. I do, of course, think ours is the best, but others may disagree. Authors of other curriculum may disagree.
Any other questions?
I had a question.
Yeah.
And nowadays is so popular data science, but we know that the formation for the data science is come for a solid formation in statistics. People have been forgetting maybe the name of statistics as a field. It's like now a statistician is like the pure math in statistics, and the data science people look like the more applied a statistical person than because he used computer and used some part of the statistics. But I'm wondering, I want to ask you is, in the coming years, people now is getting in data science, but it's forgetting about the fundamental in statistics in all data science program, and master degree, even undergrad degrees. They are forgetting about the statistical tool, and they are going to machine learning, but machine learning and this new stuff maybe don't have all the statistical fundamental than, for example, in experimental design, in quality control. And people are forgetting about a new generation, are forgetting that this exists in statistics, it's not only machine learning. How can you tackle this kind of thing in with your students, trying to give them a brief, general background, statistic intensive, focusing in data science only?
Yeah, I think you raised a good point, which is that my view of data science and statistics is foundational to it, and people who practice it, data science, without understanding statistics can do real harm. I'm thinking too of, like, some time ago, UC Irvine started a data science program that had little or no statistics in it. And within a year, they realized they'd made a mistake and had to go back and start to put in lots of statistics courses. And they're the ones who recognize that, they were paying attention, and a lot of others maybe aren't. So I think, like with our own course, I consider our introductory data science course to be a statistics course with heavy use of R and an emphasis on understanding different data types. I see it as a great precursor to AP statistics, but not a replacement, not at all a replacement. I think students need both. They need experience working with the computer and understanding how to, it boils down to, students need to understand the concepts that statistics teaches them, but they also need to be able to access the data and practice those concepts. And if we want to divide those into two labels, one called statistics and one called data science, then I'm willing to live with that. As data science being the one that teaches how to, and the statistics being the one that teaches why. So I think maybe that's the way the cards are falling right now.
Yeah, because statistics, my background have been in statistics, and we do many things related with data. We use data, and we use modeling, and we focus in another area than different from machine learning. If you introduce the student, did you introduce to the student another area different from the really data science that is nowadays, that is focusing in machine learning, on test mining, or many things like that, focusing, for example, application in biostatistics, application in quality control in another area, in social science, than is item response theory, and that kind of thing, because I think that the idea of the student now is going to data science, machine learning, and they didn't forget that it's a statistics. The statistics is all of this. Data science is just one part that deal more with heavy computer things and algorithm, but it's statistics, all of this about. That it's like the name is changing now, but no, it's the statistics.
Yeah, no, I understand, yeah.
Hey, Rob, are you working with any school districts in Ohio?
Yes, in fact, the state of Ohio has adopted several data science curriculums, including ours. I don't know which schools we're working with, but several districts.
Could I somehow find out?
Absolutely, Jerry. Yeah, just write me and
okay,
that information to you.
Yeah,
I don't know what they are offhand.
Any other questions for Rob as we wind down here? All right. Well, hearing none,
Another question is
Oh.
about the curriculum. How can you deal with the administration of the school or the government to try to introduce this kind of changes in the curriculum? Have been really hard for you? What is your strategy to go into that?
Well, that's $1 million question. I mean, Chad here on the call maybe can answer that better. There are a couple of groups that are working to try and change states and school districts' minds and convince them of the importance of this. You know, I think Ohio is ahead of the game, and Oregon and Washington and Utah. Utah's about to do a pseudo, I don't know if experiment's the right word, but Utah is adopting several different curricula and has plans to do some research on the impact of the different curricula and what the students are learning. In California, there's been a couple of studies recently announced that looked at what are called alternative math courses that include data science in that bunch to see how that affected students' pathways. The conclusion of those studies is mostly that they do no harm. They don't necessarily accelerate students, but they don't de-accelerate. They don't harm their future college careers or other careers either. So you know, slowly we're changing minds, I guess.
Okay, thank you so much.
Another one that's ahead of the game.
Okay, thank you so much.
All right. Well, thank you everybody for joining us. We're about at the end of our time, but thanks for joining us, and we'll probably schedule maybe at least one more before the end of the school year. So we'll let you know about that. Good luck to all of you AP stat teachers as you try and get your students ready for the upcoming fun. So, all right. Okay, well, thank you, everybody. And we'll have Rebecca send the slides out to the people that were signed up. And as usual, the recording, this has been recorded, so the recording will be available on the ASA website at some point as well. So, all right, thank you very much.
Thanks, Rob.